Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 9 math Pascal contest question, number 22 from the year 2020. And in it, we have this diagram where we know the distance between P and R and the distance between Q and R. And it asks us to find the ratio of the area of the shaded region to the area of the unshaded region. Give it a try, and I'll be right back with the solution. Alright, so I'm going to split this large circle PQ right in half, because we're going to focus on the semicircles. Now we have two semicircles. We have this small one QR, which has a diameter of 4, and PR has a diameter of 6. That means PQ will have a diameter of 10. Now the three semicircles I want to focus on are this large one, PQ, and then we have this medium one, PR, and this small one, RQ. So let's find the area for each of those semicircles. So let's start with the large one, so PQ. PQ semicircle. So that area is going to equal, the area of a circle is pi r squared, but since this is half a circle, it's going to be 1/2 pi, and then r, which would be the radius of this large one. Since the diameter is 10, the radius is half of that, which is 5 squared, which is going to give us an area of 25/2 pi. All right, let's do the medium-sized circle. So that would be PR. PR semicircle area. It's going to be 1/2 pi, and then its diameter is 6. So its radius is going to be 3, so pi r, or the radius squared. And that's going to give us 3 squared, which is 9/2 pi. Next, let's do the small one, so RQ. And we're going to find its semicircle area, which is 1/2 pi. Its radius is going to be 2, because its diameter is 4. So we have 2 squared. And that leaves us with 4/2, which is just 2, so we have 2 pi. Next, let's look at all of these shaded and unshaded areas. So I'm going to do a little chart here. So we have shaded and unshaded regions. So let's look at the right side of this circle. So we have this area here, which is unshaded, and this area here, which is shaded. So if I wanted to find the shaded area of the right side of the circle, that's just the area of this small circle. So the shaded area would then just be 2 pi. Now the unshaded area is going to be this semicircle here, the large semicircle PQ, which is 25/2 pi, and then subtract the small semicircle here, which is just 2 pi. So our unshaded area on the right side is going to be 21/2 pi. All right, let's do the same thing, but I want to look at the left side of this circle. So you can see that the unshaded area is going to be the area of this medium-sized semicircle, which we already calculated to be 9/2 pi. And then for the shaded area, that will be the large semicircle, which we know is 25/2 pi. Subtract the area of the unshaded area, which is the medium circle, which is 9/2 pi. And that will give us 8 pi. Okay, well now we can just add up all of the shaded and unshaded areas. So our shaded area, so we're going to look at the total amount now. Our shaded area is going to be 2 pi plus 8 pi, which is 10 pi. And our unshaded area is going to be 21 over 2 pi plus 9 over 2 pi, which is 30 over 2 or 15 pi. Now the question is asking for the ratio of the shaded over unshaded. So we'll take 10 pi divided by 15 pi. So 10 pi over 15 pi. And your pi's cancel, and that reduces to 2 over 3, or a ratio of 2 to 3. The answer is B.